Welcome. So Melvin and Felipe had let me know that I had missed a few examples from the notes. So Melvin, Felipe, and I are back to show you a few more examples. And so follow Felipe's advice, pay close attention. All right, so these examples are going to be in radians, and we're using a reference angle to draw the exact values for all 6 trig functions. And our first example is 4 pi thirds. All right, so I like to label my coordinate plane so that I can think about how far something is. So this would be 0. I haven't gone anywhere, right next to Felipe there. And right here would be pi halves, because pi halves is the same as 90 degrees, because pi is 180 degrees. So I've gone halfway around a circle. If I go 3/4 around the circle, I have to add another half. So that'd be 3 pi halves. All right, so now let's think about which quadrant that is. All right, so 4 pi thirds. Well, 3 pi thirds would be 1. 4 pi thirds is greater than 1. So this is going to be in the third quadrant. And I don't really care what my angle looks like. I just need to make sure I put it in the third quadrant. Well, I don't care how big my angle is, I should say. You draw a line perpendicular to the x-axis, right? That's where the right angle is going to be. And theta is right here next to the origin. All right, so now we want to plug in our values. All right, so let's figure out how many degrees theta is. All right, so if I go this far, it's pi. If I go this far, it's 4 pi thirds. So if we take 4 pi thirds and subtract pi from it, we'll have our reference angle. Our reference angle is always going to be between 0 and 90 degrees. Right? So this distance right here, that's our reference angle. And we find that by taking 4 pi thirds and subtracting pi. Well, I need a common denominator here, so I could subtract. So theta is 4 pi, oops, that's not a pi, that's not a 4. For some reason my 4 looks like a pi. 4 pi thirds, and pi would be 3 pi thirds. That's what 1 would, right? 3 over 3, that's the same as 1. So 4 pi thirds minus 3 pi thirds, that is pi thirds. So this is supposed to be a theta, it's looking like a 6. So this angle right here is pi thirds. Now pi thirds is the same as, so a third of 180 degrees, or 60. All right, so now if one of them is 60, we have a 30, 60, 90 triangle. So we've already found the reference angle, and that's theta, that's pi thirds. We're now going to use special triangle relationships to find the sides of the triangle. So pi thirds is the same as 60 degrees, and opposite a 60 degree angle is going to be, that's the long leg, it's going to be the square root of 3. The other leg of the triangle is going to be 1, and then the hypotenuse is 2, because this is a 30, 60, 90 right triangle, or you can think of it as a pi 6, pi thirds, pi halves right triangle, because, well, 30 degrees, that's pi thirds, or excuse me, pi 6, and 60 degrees, I'm going to make that a little neater, and 60 degrees, that's pi thirds, and 90 degrees is pi halves. And come on, just a little bit, I think they're attached. But they won't move for nothing. I'll make this one neater, and I think we're stuck with them, just the way they are. Maybe I'll erase it and make it neater. There we go. So I can make this one neater. We'll leave the others. All right, so that's just another way you can think of a 30, 60, 90 triangle. So now we've got our 3 sides. We can find all of our trig ratios just by writing down the correct sides, right? All right, so let's set up the trig. We got the trig ratios for our reference angle. And it's going to depend on which of the trig ratios we're writing. In this case, we're writing all of them. We also have to remember our signs. That's the only thing that's not up here, and so, or I haven't taken care of. We want to choose the sign based on the quadrant of the terminal side of the given angle. All right, so this is the terminal side where the 2 is, and we are in the third quadrant. And so x is going to be negative and y is going to be negative. The only thing, of course, that will be positive is r, because r is always positive. That's our hypotenuse. It's a distance. It has to be positive. All right, so now let's write down all our trig ratios. So sine theta, that's opposite over hypotenuse. And if you're having trouble with opposite, adjacent, and hypotenuse, adjacent, of course, is along the angle there. Opposite is across the triangle. And hypotenuse is opposite the right leg. So sine theta is going to be negative square root of 3 over 2. And cosine theta is the adjacent over the hypotenuse. So that's going to be negative 1 over 2, or negative 1/2. Tangent theta is going to be the opposite over the adjacent. So that'll be, let me write that down, opposite over adjacent. So that's going to be negative square root of 3 over negative 1. That's just the square root of 3. Well, I need just a little bit more space. We know how well things like to move. Maybe I could just squeeze it over next to Felipe here. All right, so I'm going to put the rest of this, little star. The rest of this is going to go over here. We'll squeeze it in over here. All right, and so our next ratio is, of course, the reciprocal of sine is cosecant theta, and that's going to be the hypotenuse over the opposite. All right, so that's going to be 2 over negative square root of 3, and when we rationalize that, okay, that's going to be negative 2 square roots of 3 over 3, because we usually just put the negative in the numerator. There's cosecant. All right, let's see if we can squeeze secant over here. All right, that's going to be the inverse of cosine, so that's going to be hypotenuse over adjacent. So that's going to be 2 divided by negative 1, or just negative 2. And, oh, where will we squeeze in the last one? Let's put it over here by Felipe. So cotangent theta is the reciprocal of tangent theta. That's going to be adjacent over opposite. So that's going to be, the adjacent side is negative 1. Negative 1 over the negative square root of 3. And when we rationalize that, we're going to have negative square root of 3 over 3. So here's all our trig ratios. We have sine, negative square root of 3 over 2. We have cosine, negative 1/2. We have tangent, which is the square root of 3. Way over here, we have cosecant theta, which is negative 2 square roots of 3 over 3. We have secant theta, which is negative 2. And last but not least is cotangent theta, and that is over here, negative square root of 3 over 3. All right? Oh, excuse me, positive square root of 3 over 3. We have two negatives. They're going to cancel. Positive square root of 3 over 3. And so actually our only two positive trig ratios are tangent and cotangent. Right, because they use x and y, and so those two negatives will cancel them out. Everybody who uses one negative and the positive r is going to be negatives. That's everybody else. All right, so here I kind of crammed in. Let me see if I can use my space a little bit better on the next problem, okay? And plus, Melvin and Felipe aren't going to be joining me in the next problem. All right, they're just going to watch from here on in. All right, so now let's try this one, since we changed the page. 5 pi thirds. All right, so let's see. So this would be 0, and this is pi halves, and this is pi, and this is 3 pi halves. All right, so you might think, well, I don't know how far 5 pi thirds is. You might say, oh, I know it's more than 1, but I don't know if it's in the third quadrant or the fourth quadrant. So why don't we change pi into thirds, all right? So this would be 3 pi thirds. Okay, we know it's more than that. Well, how about, though, 3 pi halves? I can't change that into thirds. Well, let's change 5 pi thirds into something we could, that would have something in common with the two. And that is, what if we changed it to 6? All right, because we could change halves into 6. All right? So 5 pi thirds is the same as 10 pi 6, right? I just multiplied numerator and denominator by 2. All right, so 3 pi halves, right? So now I'm going to multiply numerator and denominator by 3, because 2 times 3 is 6. That would be 9 pi 6. All right, so 3 pi halves is only 9 pi 6. We want 10 pi 6. So we are going to be in this quadrant. And you can also think, well, 6 pi thirds, that would be 2. And you might remember that a third is less than a half, so it's got to be in the fourth quadrant. All right, so we're in the fourth quadrant. So our reference angle is this angle here. All right, so how are we going to get that angle? We're going to take, what happened to my angle? There it is. How are we going to get that angle? Of course, this is our right angle, right, because we're always perpendicular to the x-axis. All right, so how we're going to find what that measure is, we're going to take, so we're in the fourth quadrant, we're going to take 2 pi, and we're going to subtract, so if I go all the way here, that's 5 pi thirds. So we're going to take 2 and we're going to subtract 5 pi thirds. So that would be the same as 6 pi thirds minus 5 pi thirds. Well, that's going to be pi thirds. So this one is pi thirds as well. And well, we just had a pi thirds, right? So this is a very similar problem, except instead of being in the third quadrant, it's in the fourth quadrant, right? But the same reference angle. It's a different angle, but it's the same reference angle. So this is going to be the square root of 3, and this will be negative because our y is negative, right? So again, this is a 30, 60, 90 triangle, if you like to think of it in degrees. Right? And pi thirds is the same as 60 degrees. Opposite 60 degrees is the long leg, the square root of 3. The adjacent side is going to be 1. That'll be positive because that is a positive x. And this will be 2. Now that we've got our, we've used a special triangle. We did this, we did this, we did this. Now that we've used a special triangle to find the relationships and find the sides of the triangle, now all we've got to do is set up the trig ratios. This is the easy part. All right, so we've got sine theta, which is opposite over hypotenuse, and that's going to be negative square root of 3 over 2. We got cosine theta, that's adjacent over hypotenuse, and that's going to be 1/2. That one's positive. We have tangent theta, which is opposite over adjacent, and that's going to be negative square root of 3 over 1, so that's just, what happened to my negative? That's just negative square root of 3. And again, what happened to my negative? And then we have the inverse of sine, which is cosecant. There we go, it's cosecant theta, which is hypotenuse over opposite. So that's going to be 2 over negative square root of 3, so we'll just rationalize it, and we can just put the negative in the numerator. So that's going to be negative 2 square roots of 3 over 3. We're almost done. We need secant theta, which is the inverse of cosine, so that's going to be hypotenuse over adjacent. So that's going to be 2 over 1, which is just 2. And last but not least, we have cotangent theta, which is adjacent over opposite. All right, so that's going to be 1 over negative square root of 3. And then we'll just rationalize that. So that's going to be negative square root of 3. Whoops, there's my negative, over 3. And there we go. So there are all of our trig ratios. Sine, there's a negative there, I hope you can see it. Cosine, tangent, cosecant, secant is 2, and cotangent is negative square root of 3 over 3. Now we've reviewed what sides are each of the trig ratios, so maybe I won't write the opposite and hypotenuse and the adjacent hypotenuse and all that stuff. Maybe we'll just write the answers on the next one. All right, so that's number 2 in the notes. Let's do the next one. I'm using space better, At least I squeezed everything in without having to write all around Felipe and Melvin. Oh, that one, by the way, was not in the notes. The one that was all crammed in, that was in the notes, but yours won't be as crammed in as mine was. All right, so now let's go to 3 pi fourths. All right, so we have 0, we have pi halves, and then we have pi and 3 pi fourths. Of course, 3 pi halves, excuse me. 3 pi fourths is smaller than pi. It's larger than pi halves, right? Because this would be the same as 2 pi fourths, right? And this would be the same as 4 pi fourths. So I hope you see that this is right smack in the middle. Of course, remember when we draw the side of the triangle, it's got to be perpendicular to the x-axis, so that's going to go right there. And our angle is right along the origin. All right, so this here is 3 pi fourths. We want theta there, and I bet you already pretty much got it in your head, right? So how are we going to find theta? We're going to take pi fourths, or which is say, excuse me, 4 pi fourths, or pi. So we're going to take pi, which is 4 pi fourths, and subtract 3 pi fourths, and that gives us pi fourths. So this angle here is pi fourths. That makes sense. 3 pi fourths and pi fourths. That'd give you 4 pi fourths, or pi. All right, so we have our angle there. All right, so now that we've got the reference angle, we drew the angle, we got the reference angle, we need to use our special triangle relationships to find the side of the triangle. So pi fourths is the same as half of 90 degrees. All right, so that's 45 degrees. This is a 45, 45, 90 right triangle. I'll write that here. 45, 45, 90 right triangle. Of course, it's isosceles. All right. So that means these are the legs are the exact same measure. And of course, the hypotenuse is the square root of 2. Right? Because 1 squared plus 1 squared, that'd be 2. And then take the square root, you got square root of 2. All right, so that is our hypotenuse. All right, so now we're going to set up the trig ratios. We're going to do all 6 of them here. All right, so sine theta, I'll just say it. I won't write it down. Opposite over hypotenuse. All right, so that's going to be 1 over the square root of 2. Oh, one thing. This net one here is negative, right? Because the x's are negative. Right, so we got to make sure we have the right sign. Right? Now we've got the right sign there. All right, so sine theta is 1 over the square root of 2. And then we'll rationalize that. So that's the square root of 2 over 2. Cosine theta, right? So that's the adjacent side. That's negative 1 over the square root of 2. So we're going to rationalize that. So that's going to be negative square root of 2 over 2. And then tangent theta is the opposite over the adjacent. 1 and negative 1, that's negative 1. Cosecant theta is the inverse of sine. So that's going to be the square root of 2 over 1, and that's just the square root of 2. Secant theta is the inverse of cosine. All right, it's going to be almost the same thing, square root of 2, but this time it's going to be divided by negative 1 because it's going to use the adjacent side, hypotenuse over adjacent. So that's going to be negative square root of 2. And finally, cotangent is the inverse of tangent. And guess what? We're going to have the exact same thing. Now we'll have negative 1 over 1, which is still negative 1. So cotangent and tangent are the same thing for the 45, 45, 90 because they're using the same two sides. They're using the same two sides, and those two sides happen to have the same measurement. The only thing different in this case is one is positive and one's negative. All right, so there we go. That's all there was to this one. We're just cruising right along. All right, so 5 pi 6 is the next one in the notes. And that's this one, except it's, I'm sorry, negative 5 pi 6. So the negative means we go counterclockwise. So negative angles go counterclockwise. All right, so we're going 5 pi 6. All right, so this would be 0. This would be 3 pi 6. All right? Because that's half. This would be pi halves, and 3 is half a 6. This would be 6 pi 6. Well, 5 is definitely more than 3, but less than 6. So our angle here is going to be right here. Of course, we have to go perpendicular, right? So this part here that I just drew in, that's the negative 5 pi 6 part. Sometimes I don't draw that in, and I should. And that right there is what we get when we take 6 pi 6 and subtract 5 pi 6. All right, so theta here is going to be pi 6. All right, so 5 pi 6 plus pi 6, that's going to give us a whole pi. All right, it doesn't matter that it's negative. All right, you don't need to use that when you're calculating. Just know that you're going in the negative direction. Right? So if it was positive 5 pi 6, it'd be up here in the second quadrant. It's negative 5 pi 6, so we're going the other direction. So we're going to be in the third quadrant. All right, so this is pi 6 over here. And that's our 30, 60, 90 right triangle. Opposite pi 6 is the 1. In this case, it's a negative 1 because we're in the third quadrant. Along the adjacent side here is the square root of 3. That's the long leg because it'd be opposite pi thirds. And then the hypotenuse is 2. All right, so now we've got our triangle. Now all we need to do is get our ratios. All right, so sine theta is going to be the opposite over the hypotenuse, negative 1/2. Cosine theta is the adjacent over the hypotenuse. Oops, this is a negative 2. And that's going to be negative square root of 3 over 2. Tangent theta, opposite over the adjacent, is going to be negative 1 over negative square root of 3. We'll rationalize that, and we'll cancel out those negatives. So we're going to have the square root of 3 over 3. Cosecant theta is the inverse of sine. That's going to be 2 over negative 1, or negative 2. Secant theta is the inverse of cosine. That's going to be 2 over negative square root of 3. And then we'll have to rationalize. So that's going to be negative 2 square roots of 3 over 3. And then finally, cotangent is just the inverse of tangent. Right, now it's going to be adjacent, negative square root of 3, over the opposite, which is a negative 1, and those negatives will cancel. That's just a square root of 3. So there are our 6 trig ratios. We're getting a little faster with this, aren't we? All right, so you just draw the angle. All right, so technically the angle that I'm drawing, this is the principal angle. This is the angle that we're given. What we use to evaluate is our reference angle. So if we looked at the others real quick, a little review before we go to the last one. So I did draw this one. This one is our reference angle right here. Excuse me, our principal angle. And then the reference angle, of course, is right here, the pi fourths. Oops. I have a feeling, there we go. I knew it came out weird. We'll just erase part of the triangle. Reference angle. Not good enough. All right, and then over here, the super messy one. Actually, no, the one right before it was a super messy one. And we're just waiting for it to change pages. There we go. So this, the green here, this is our principal angle. And then inside the pi thirds, that's the reference angle. Okay, so the reference angle is always less than 90 degrees. Right? And it's the angle, if we were to take the angle that we're given and create a triangle, right, that would be our reference angle. Right? And so again here, the blue one is the principal. This is the messy one. And Felipe is saying, it's not my fault it's messy. This is the principal angle. And then right over here in green, that pi thirds, that's the reference angle. Okay? So that's how we get those. Right. Although this one may be messy, but it is colorful. And it's got Felipe and Melvin, so that's, definitely worth it. Okay, moving on. We're going to do, I think I have, what, 2 examples? 2 examples. We did that one already. And so we're on, and I think the last two examples, we're just finding a single angle, so that should be pretty quick. All right, so we want to use a reference angle to find the exact value. We want to evaluate secant 210. So this one was in degrees. All right, so for in degrees, this is 0, this is 90, this is 180, this is 360. Yeah. Okay, we're having trouble adding 90s. This is 270. This would be 360 if it went all the way around again. All right, so 210 is going to be in this quadrant right here. All right, this would be 210 degrees. And it's actually, it's going to be a little closer to 180, but how I draw the angle is not that important. So long as I draw the triangle correctly, it's got to go perpendicular to the x-axis. All right, so this whole angle from here to here, that's 210 degrees. Our reference angle is right here, and that just goes from here to here. It's the angle in the triangle. So notice that if we take away 180 degrees, we take away all of this, right? All of this, right, to 180, we'll have our reference angle. All right, so we're going to, our reference angle, our reference angle theta is just going to be 210 minus 180. All right, so theta is 30 degrees. All right, so theta right here is 30 degrees. Right, we know opposite 30 degrees. This is again a 30, 60, 90 triangle, so this is, come on, 30, 60, 90 triangle. So this is 1 square root of 3 and 2. Oh, that looks so lovely. We're in the third quadrant. I'm even going to be in the third quadrant. So these are going to be negative. So x is negative and y is negative. So negative 1, that's y, that's a negative. And the square root of 3, that's negative. All right, and that's, of course, our adjacent side. I haven't labeled these. I guess I don't know if I should. And these are the hypotenuse. I think I'm lazy here. So opposite the triangle, opposite the angle there, that would be the opposite side. The adjacent forms part of the angle. I probably should have labeled that, and I did not in some of these examples. All right, so, but we can do that. I can go back to especially the ones that are in your notes. All right, so there we have adjacent, opposite, and hypotenuse. We want secant. So secant theta to begin with, inverse of, or I should say inverse, reciprocal of cosine. So this is going to be hypotenuse over adjacent. Right? So it's the reciprocal of cosine. Uses the hypotenuse and adjacent. So secant 210 is going to be, the hypotenuse is 2. And the adjacent is negative square root of 3. And all we have to do is rationalize it, and we're done. So, and wait for the rest of my words to come up. There we go. So we have negative 2 square roots of 3 over 3 is our final answer. We're done. All right. So just in case, let me go back to the last one before we do our last example. All right. So sometimes I kind of forget to write those adjacent, hypotenuse, etc. in, but the hypotenuse is always the opposite the right angle. The adjacent forms part of the angle. It also is along the x-axis. So the adjacent here will always be along the x-axis, and the opposite is across. It's that y distance. All right, so all the triangles are set up the exact same way. So where opposite is, where adjacent is, where hypotenuse is the same in every single one of these triangles. All right, so now let's go to our last example. And this time we're evaluating, but for radian measures. All right, so 0, pi halves, pi, 3 pi halves. All right, so we're in fourths. All right, so pi halves is the same as 2 pi fourths. Right? And pi is the same as 4 pi fourths. And 3 pi halves is 6 pi fourths. So 7 pi fourths. And of course 0, we'll go back to 2 pi after we go all the way around the circle. Now it's 2 pi. And that's going to be 8 pi fourths. So right halfway is 7 pi fourths. All right, so this is our principal angle. All right, is 7 pi fourths. All right, our reference angle is right here. All right, and so notice that we've basically gone almost around the circle, all right, except for that little piece that's left after our principal angle. So our reference angle, angle, there we go, is going to be, because we're in the fourth quadrant, is going to be 2 pi minus 7 pi fourths. Oops. And when we do that, we will have that leftover, that theta there. So theta is 2 pi minus 7. My 7 keeps looking weird. 7 pi fourths. There we go. 2 pi is the same as 8 pi fourths. Oops. And so if we take 8 pi fourths minus 7 pi fourths, theta there is pi fourths. I don't know what was so hard about that for me. So this is pi fourths. That's our reference angle. All right, so this is a 45, 45, 90 right triangle. We got 1, except that's negative. We got 1, and we got square root of 2, and we want cotangent. Now, that's the easy one. So cotangent 7 pi fourths. All right, that's going to be the adjacent, which is 1, over the opposite, which is negative 1, and this is negative 1, and that's it. That was an easy one. No rationalizing, no nothing. All right, so now we've got a little word from our friends, Melvin and Felipe. I think they're over here, waiting patiently. There we go. And they wanted to say, so Melvin says, thanks for watching our reference angle podcast. And Felipe says, we hope you enjoyed it. And I hope that you have enjoyed Melvin and Felipe lending a hand and joining us in these series of podcasts. They've been very good sports about it all these years. All right, so thanks for watching, and bye for now.